Dear students, today we'll discuss the construction of DC machines. Subsequently, we'll discuss the principle of operation, the types of DC machines, the characteristics and applications of a DC machine. Just if you look into the overview of the direct current machine, the direct current machines are divided into two types of machine. One is called as a DC generator and the another one is called as a DC motor. Under DC machine heading, we are studying DC generator as well as a DC motor. Here we are studying a DC machines, means its output what we are expecting is a DC. If you are taking a DC generator, actual generated voltage in the armature of the DC machine is a AC, then what we want is a DC output, that you are getting a DC output from the AC generator in the armature is through the process of what you are calling as commutating process, and the equipment what we are calling a part of a DC machine is called as a commutator. Therefore, you have got a commutator in the machine. These machines also called as the commutating machines. We know that in the most of the electrical machines in service, the different applications what we are seeing around us is the AC in the nature. However, the DC machines have got a limited the applications, especially where we need a very fine control of the DC motors. Then we are preferring a precise and fine control is required. We are using a DC motor. I told you we have got finding some few applications of the DC motor. However, they are not at all using a DC generator, because all the generation all the electricity what we are getting is from the AC generation. Okay, some of the applications of the DC machines are paper mills, that's steel mills. Okay, in the mining they are using machine tools, oil rigs, robots, and petrochemical industries they are using the DC motors. Then I told you the electrical machines are categorized into generator and motor. That is, the generator is which is converting a mechanical input into electrical output. That machine is called as a generator. And if the machine which converts the electrical energy into a mechanical energy, that machine what we are calling is the motor. In the case of the generator, the mechanical input in the form of hydro, thermal, nuclear, these are all called as conventional energies that is available. In the form of non-renewable energy sources such as the wind, solar and biogas and other things. Non-conventional energy also we are using to convert a mechanical energy into a electrical energy through a machine what we are calling is a generator. Then if you are looking into the ideal machine, the block diagram here, if there is an electrical system, from the electrical system if you want a mechanical system, then the machine has to convert the electrical energy into a mechanical energy. Then the flow of energy is from electrical to mechanical, then it is called as the motor. Whereas if I have got a mechanical system, I require the electrical system applications, then there is a flow of energy from mechanical to the electrical. Therefore, there is a conversion of mechanical energy into electrical energy, that is called as the generator. You can see here the input to the machine is electrical power input, therefore expected output is the mechanical output. Then this machine is called as the motor, or it is the motor action. In other words, in the case of the generator, the input to the machine is the mechanical input, whereas the output what we are getting is the electrical. Then this machine is called as a generator. Then if you look into the construction of either a DC generator or a DC motor, it is the construction is one and same. Then if you are inputting the electrical energy, it is act as a motor. If you are inputting a mechanical energy to the DC machine, it is act as a generator. The construction, I told you that is fall under the rotating machine. It has got two parts. One is called as a rotor, the another one is called as the stator. The rotor is nothing but the rotating part of the machine. In the rotating part of the machine of a DC, it is consist of armature conductors in which there is a induced voltage. Whereas in the case of the stator, which is a stationary part of a DC machine, it will produce the magnetic flux, that it is called as a field. You have got an armature system, you have got a field. In the armature, you have got a armature conductor. The purpose of the field is to produce the magnetic field. We know that according to Faraday's laws of electromagnetic induction, the voltage is inducing only when either the conductor cuts the magnetic flux, there is an induced voltage. What do you need? Conductor cuts the magnetic flux. We need conductor, we need the flux, then we need the relative motion between the conductor and the field. Therefore, based on this principle, we need three things to generate the electricity. One is the armature, in which there is an induced voltage. Then it has to cut the magnetic field, therefore the field system is required. Then we need the relative motion between the armature and the field, we need the mechanical energy. Therefore, it is listed here, the purpose of the armature is to provide the energy conversion in the DC machine. There is an induced voltage in the armature conductors. Then the purpose of the field system in the DC machine is to provide the magnetic field. It is produce the magnetic field, so that there is a field is producing from the stationary part of the field. The conductors are rotating by means of a mechanical energy, so that there is an induced voltage in the armature conductors. Therefore, the energy conversion takes place in the armature winding. The field which is producing the magnetic field, usually there are two types of producing the magnetic flux. One is by a permanent magnet. They are rarely used because their capacity is limited. However, nowadays all the machines we are using the electromagnets to produce the magnetic flux in the machine. You look into I told you there are two parts. One is the rotor, the another one is stator, and also I reiterate that is the induced voltage is AC in the nature. Then I have to convert that into DC. Then what we need is the commutation process. Therefore, there are three parts in the DC machine. One is called as the rotor, the another one is called as stator. Then the generated voltage is the AC. Then what I need is a DC. For that I need a commutator. If you look into here, this is your armature, on which there is a number of conductors are placed here. They are connected. These conductors are connected to a commutator segment. These commutator segments are touched by the two brushes. One is called as a positive brush, another one is called as a negative brush. Here the generated voltage is AC, then it is connected to commutator. Here there is a conversion of AC into DC. Then outside the word, what I am getting here is the DC output. I told you this is the rotor part, the commutator part. Then you can see is the important part of the machine is also the field, which is producing the magnetic field here. This is a field system, that is a stationary part. This is the armature, which is a rotating part. The commutator, which is making a commutation process, converting AC into a DC. Then if you look into the construction part, both the stator and the rotor are made up of ferromagnet, good magnetic material. It is made up of good magnetic material. And the slots are cut on the inner periphery of the stator and the outer periphery of the rotor. That is, the rotor and the stator are made up of laminations. On its outer and inner periphery of the rotor and stator stampings, we are making a slots to accommodate the conductors. In the case of the armature, you have got armature slots. In the armature slot, you are placing the conductors. If you look into this figure, you come to know here there are the slots on the armature. In this armature slots, you are placing a number of conductors here. You are placing a number of conductors. These are called as armature conductors. Whereas here you have got a field winding. Because of flow of current here, it is producing the magnetic flux. These are called as the field winding. This is what we are calling as the armature winding. Therefore, the conductors placed in the slots of the stator and the rotor, the conductors are interconnected. The number of conductors, they are connected in a particular fashion. That is what we are calling as winding. In the case of the armature, we are placing the conductors in the different slots. All these conductors are connected in a particular fashion. That connection and the total bunch of conductors connected in a particular fashion, it is called as the armature winding. The winding through which a current is passing to produce a magnetic field, that what we are calling is the field winding. You have got a two winding. One is the armature winding, in which there is a induced voltage, and in the field winding we are passing a current so that it has to produce the magnetic flux in the machine. You can see here the three important parts of the machine. One is, this is a rotor, this is stator, they are producing the magnetic flux, that is N and S pole I have shown here. This is the armature rotating part. Then the important part is this, that is what you are calling as the commutator. Here there is a conversion of the AC induced in the armature conductors is converted into a DC. It is connected to the outside the board, or it is connected to load through the brushes. One is called as a positive brush, the another one is called as a negative brush. That is, this is pole stationary part, this is the armature rotating part, the commutator which converts the AC into DC, then the DC output is connected through a brushes to the load. Then the first stationary part of the system we will see in detail. The field system is the stationary part of the machine. Here you are using, to produce the magnetic flux, you are using electromagnets over the permanent magnets, because the permanent magnets not producing much of the magnetic flux. The purpose of the field system is to produce the magnetic flux in the machine. This assembly of the field system is rested on yoke. This outer part of the machine, it is called as the yoke. Okay. The pole cores are made up of sheet steel laminations. All the system in the electrical rotating machines, they are made up of a lamination to reduce the iron losses in the machine. Then all these laminations are stamped together, they are separated by insulation. There are two types of windings you come across. One is called as a series field winding. The series field winding means the field winding which is producing the magnetic flux, which is connected in series with the armature, that is called as a series field. And if the winding is connected across the armature, it is called a shunt field. These two you are studying in detail in the types of a DC machine. At this point you have to remember that the field system is a stationary part. It is producing the magnetic flux. These are electromagnets. Then there are two types of the field winding. One is called as series field winding. The another one is called as a shunt field winding. And the field system is made up of sheet steel lamination to reduce the iron losses. This is about the shunt field and the series field winding. That we will deliberate in detail when we are discussing about the different types of the DC machines. The next part of the DC machine is the armature, in which there is a induced voltage. It is a rotating part of the system. The rotating part of the DC machine, what we are calling is the armature. Usually the armature is consisting of, there is a rotating part, that is a shaft, on which a laminated cylinder core. Once again, it is also made up of laminations, and its outer periphery we are getting a slots. In the slots we are placing the number of conductors. These conductors are connected in a particular fashion, then it is forming the armature conductors. Suppose if the mechanical twist is given to the rotor, and the rotor means the rotor conductors are rotating, there is a stationary magnetic field, therefore there is a induced voltage. The nature of the induced voltage in the armature is the alternating in the nature. That we'll study in principle of operation. You can remember here the insulated conductors are put in the slots in the armature. Then these are connected in a particular fashion. It is called as a armature winding. There are two types of winding here wound. One is wave winding, the another one is the lap winding that we'll discuss. Then the third important part of a DC machine is what you are calling as the commutator. That is, the induced voltage is AC in the armature. The what we required from the machine is the DC. The DC output you are getting by the process of commutation through a small the part of the DC machine, that is what you are calling as the commutator, and through the brushes you are getting the electricity to the load. The alternating voltage is produced in the coil rotating the magnetic field. To obtain, it is not dark, it is a DC current in the external circuit. A commutator is needed, the commutator which rotates with the armature. You can see here this whole rotor assembly. See, this is, it looks like a solid body, but however it is made up of small laminations. All the laminations are stamped together. It is, looks like a solid body. See here, these are the slots on the outer periphery of the rotor in which the armature conductors are placed. At the same time, you can see here, this is the commutator. This is the commutator. From this conductors, it is connected to the commutator. From there is a brush here, you are connecting to the load. That I am showing in the next slide. You can see it's a total assembly of the rotor and rotor. It consists of the armature as well as the commutator. You can see here, these are the slots in which these are the armature conductors are placed. These armature conductors are connected to the commutator segments. It is a commutator segment. Then from the commutator segment, there are two brushes that I'll show you in the next slide. Here you can see here, these are the armature conductors. This is the commutator segment. Then that is the brush assembly which is touching the commutator segment. Then there is the induced voltage AC here. It is directing the AC DC current to the brush, and you are connecting to the load here. Okay. How exactly you are getting the DC from the AC, that I will explain when I am explaining the commutation process in the principle of operation. I told you there are two types of winding they are using in the case of the DC machine. One is called as a lap winding and another one is called as a wave winding. In the case of a lap winding, the number of parallel paths, what we are calling is A is equal to B, whereas in the wave winding it is A is equal to 2. What do you mean by the parallel paths? If you have got 100 total armature conductors and if the number of poles is 4, then we have got 4 different circuits in the case of lap winding. Means 25, 25, 25 they are connected in a parallel. That is in the case of the lap winding. Whereas in the wave winding, there are 100 conductors irrespective of the number of poles. There are 4 number of poles. However, we are getting the 50-50 conductors in the 2 slots, 2 sets of parallel paths we are getting. Then from that we are tapping the electricity. In the case of the lap winding, we are making a parallel path equal to number of poles, whereas in the case of wave winding, we have got only 2 parallel paths what we are getting. Then they are given the name lap and wave winding because here you can see here in the case of the lap winding, the windings are overlapping each other, therefore it is called as a lap winding. Whereas in the case of the wave winding, these are progressive winding and it is looks like a wave, therefore it is called as a wave winding. In the next class, we will discuss the principle of operation of a DC machines and types of a DC machine.